What is the second step to adding and subtracting fractions? So, writing the fractions with their individual LCD is the second step to adding and subtracting fractions. So we have unlike fractions, and we're going to state here the second step. So they have to be equal, they're equivalents, right? And they have to be in a form of the least common denominator, right? So we're adding and subtracting, remember. So here, for example, we have 3 over 5 plus 1 over 10. Well, what's the LCD? And make sure that we maintain the same fraction. All right, so the LCD here is 10. Let's multiply our first fraction by 2, numerator and the denominator. We get 6 over 10. And since the LCD is 10 here, we simply multiply 1 over 10 by 1, giving us 1 over 10 once again. And now addition is simple. So here we say 6 over 10 plus 1 over 10. This is known as the second step, when we maintain the same fraction and we write it with their least common denominator. So let's move on to our second example here. We have 2 over 5 minus 1 over 20. So now once again, to give you an example of the second step, we're going to write the least common denominator. In this case, it's 20. So let's multiply our first fraction by 4. 2 times 4 in the numerator is 8. And 5 times 4 is 20 in the denominator. And for our second fraction, we're going to multiply everything by 1, giving us the same thing as 1 over 20. So this statement right here is ideally step number 2. They're equal, they're the same fraction, they have equivalents, and they're in their least common denominator, giving us the ability to add and subtract easier, right? Now if we finish 8 minus 1, well, that's 7, and giving us a total difference of 7 over 20. Let's throw in another example here. Example, we have 7 over x plus 4 over 10. Well, here we're going to multiply the first fraction by 10, numerator and denominator. And for our second fraction, we're going to multiply x, numerator and the denominator, giving us 70 over 10x plus 4x over 10x. Notice how here we have a least common denominator of 10x. All right, 70 over 10x. So now we can do some addition. You know, if we want to go ahead and add it, 70 plus 4x over 10x. And that's kind of